All right. Hi, everyone. Y'all, this is where you say hi. Thank you so much for coming, and thanks to those of you who have joined us here online. This is our first talk in our new colloquium series on critical scholarship in the College for Education and Engaged Learning. And we are very excited to introduce our first speaker, who is a professor in the Department of Educational Foundations, an associate professor. Liz Rivera Rodas is going to be speaking today on her talk, The Math is Not Mathing: The Impact of Historical Residential Segregation on Latinx Mathematics Course Taking in High School. She has promised that her talk will be accessible to those of us who are historians, as well as other folks who are not experts in quantitative analysis. So I am really delighted to welcome her to the podium. Liz.
Thanks, everyone. Thank you, Zoe. I did not promise that. I said I was trying to. That I was making it as user-friendly as I thought I could make logistic regressions. So there is an interactive portion of my presentation. So if you have a phone, a laptop, I think those are the only options, go on to joinpd.com and put in that code, and it will also allow you to follow the slides on your device as well. So I'll wait a few minutes for that to happen. There's no space. Oh, because you get to sign in. He needs to sign into Google too. Okay, so the code is still there, just joinpd.com, and the code is going to be constantly right in the corner. So if you get kicked off for some reason, just put that code in. So as Zoe mentioned, my talk is about the math is not mathing. Essentially, it's looking at the impact of historical segregation in the United States and the impact that it has had on Latinx academic achievement across the spectrum. Because I do get grant funding, I have to say, my work is funded by the Spencer Foundation and the Institute for Research on Poverty's Emerging Poverty Scholar Fellowship. So before I get into my whole spiel, I want you guys to think about how and why does residential segregation matter in K-6 classrooms? And don't worry if you're a secondary ed person or a higher ed person, there are questions later about that as well. But first I want to concentrate on K-6. So on the Join PD, there is an option for you to write your responses there. Okay, so a few of you were able to enter it on. So a few responses, essentially, school segregation tends to correlate highly with educational quality in terms of funding, resources. Mainly that's what everyone wrote. There's a lot of things with the correlation between resources and segregation, right? Inequitable resources, unequal distribution of resources and all of that. So, let's hide your responses now. So that's for K to 12, K to 6 classrooms, right? Has that changed when we're thinking about middle and high schools? So think about how middle schools and high schools are zoned in comparison to K to 6 schools. So some responses have a lot to do with the fact that high schools have larger school zones. This is especially the case when you're looking at places like New Jersey, right? So New Jersey, for the most part, there's one high school in a lot of the towns and a bunch of middle schools, and we're probably like 2 middle schools and a bunch of elementary schools. So school segregation, you see a lot more in elementary schools in places like New Jersey where this happens versus in high school at the school level. Some of the things that were mentioned here are things like in school segregation that still occur, right? And there's also things with resources and also things that will impact college access. So thank you for whoever said that, because that goes right into the next question about higher education, right? So how does residential segregation matter? Why does it matter in higher education? Because most people, not everyone goes to school, to college in the same area in which they actually went to K-12. So why would that matter? Does it matter? Yes, Helen Rose. No, silly you just, yes. I wanted you guys to think about the questions before I gave you my whole, this is why we do this research business.
Get to work, Jaime. More typing over there.
We are the College for Education and Engaged Learning.
Yeah, you're engaged.
So college readiness is going to vary based off of these resources, right? So based off how you went to elementary school, high school, middle school, all of that is going to impact how you go to college. So a lot of these things I'm going to talk about in a second: social reproduction, sorting function in higher ed, on all of that, whether or not you're even capable of going to college, right? So that's what a lot of my research looks at. I look at the fact that places don't have certain courses that are even necessary to go to college. When we apply to college, it says you have to take at least calculus. What happens to students who go to schools that don't provide a calculus course? They're not eligible to go to a lot of colleges because of this. And a lot of that has to do with the way that resources are given to schools. Let's see. So Helen Rose, you'll be happy. Here are some answers. So residential and school segregation are intrinsically linked, especially in the United States. Historically, my historians in the audience, we have redlining, de facto segregation, racism, all of that has impacted the way in which people live across the United States. And because the United States functions in a way that you have to go to school where you live, that means that the school systems look very similar to those neighborhoods. So if your neighborhood is all Black, your school is not going to look all white. It's not going to have a lot of resources because in the United States, race and socioeconomic status are tied together because of all the things that have happened historically. And we need to recognize that fact, that the historical things that have happened still have an impact on everything. So currently over half of Black and Latinx students in the United States, regardless of socioeconomic status, do attend a school that is 75% minority enrollment. And with that means that there's lower resources because higher minority enrollment means that there's low socioeconomic status within that school, so lower funding. So if we look at how schools are funded, it is funded out of property taxes, primarily in the United States, and then we get state funding added to it, then we can have federal funding. If your property tax base is really low, you don't have a huge resource base. And there's other ways to fund all of that, right? So there's the PTAs and all that great stuff that come with money and resources that some areas don't have. So a lot of that still continues. I do this. So if we look at how redlining is, so I put a redlining map. This is actually of Essex County. And I try to do it in a way that I could remember where things were, but I remember seeing Montclair somewhere. It was the normal school. It's a 1930s map. But Montclair is up here in this little corner. So if you can see, the green is the places that people thought were quality areas to buy homes. So they had lower mortgage rates. The red areas are the places that were deemed unmortgageable. I just made up a new word. We're going to roll with it. Does it have both of them? So why did I skip a slide? I feel like I did. I did. So I'm going to talk about redlining for a second, right? So I'm sure that most of you understand what redlining is for the most part. Redlining was something that was created because of the Great Depression. Out of the New Deal, they wanted to make sure that people were still able to buy homes. So mortgages came about so that people could spend 30 years paying for their home instead of just providing a lump sum of cash, because I think that's how it used to work. So because of this, they created the HOLC, the homeowners, something you're going to have to Google it later because it was on a slide, where they created these residential maps. So these are redlining maps, and they were created for about 300 cities across the United States. And for the most part, the places that were red or grade D, so they were graded A through D. A was actually the red line areas, the places that were not places that you should live. So anywhere where homes were not homogeneous, where there was a lot of African Americans. In some cases on the West Coast, they did talk about Mexicans and how you should not live in those areas either. So those areas were considered to be red areas. Green areas are the grade D. So there were the places that were said that these are the places that mortgages should go. And they had homogeneous homes. They were nice and predominantly white. So this just reinforced the residential segregation that was already occurring. So now we already have separate areas where people are living, but now it's impossible to buy homes in certain areas. So you're not able to get a mortgage in the red areas because the banks won't back you. You can only get it in the green areas or the blue areas. So why focus on Latinx students? Because redlining, when most people think about it as something that has impacted African Americans. If we think about how Latin Americans have come into the country and where we have all migrated to, it looks exactly like where African Americans have been, right? So the Latinx population within the United States actually disproportionately lives in former red line areas, more so than the African-American community currently does. So if you look at these places, the proportion of Latinx in red line areas mirrors or exceeds those of the proportion of Blacks in those red line areas. So that's why I look at it. Also, for obvious reasons, I am Puerto Rican and it's interesting to me and I want to research what's interesting to me. It makes it easier. Third, the Latinx population is the largest and most rapidly growing minority population in the United States. And so if we are to look at the growth of the United States as a whole, if the largest minority population is unable to go to college because of these limitations, what does that look like for the economy of the United States moving forward if an entire subsection cannot go to school? And because of the immigration patterns of Latin Americans, there is an increasing number of students in K-12 that are from Latinx backgrounds. So this project in particular looks at the structural barrier of advanced level math course availability due to residential segregation in high school. So looking at high school math courses. So if we were to look at math course sequences, traditionally you start at Algebra 1 in freshman year of high school. That doesn't always happen. Some places you take it in middle school, some places you don't get to Algebra 1 until your senior year. So it depends on what courses they have. And a lot of that has to do with tracking. Some of it has to do with what the middle schools offered. Some of it has to do with what course availability there is. So looking at the course availability of high schools that are in historically redlined areas and how that contributes to the low enrollment of STEM post-secondary degrees for these Latinx students. So I use a bunch of theories in my work. I am trained in sociology and economics. So I'm sure that most of you know most of the sociological theories like Coleman and social capital and all of that. So I will go straight to the economic theories where everyone is making faces for. Yes. So one of the theories I work with most is the Tibu theory, which is vote with your feet. So the money that you have, you take it and you go there. So when you went and you bought a house, you decided to take all your resources to whichever town you went to. And that is your option as someone who has that sort of capital. Some people don't have that option. But because people who have the option to move places, it tells you where those resources go. So it's the same thing like gentrification. When Hoboken started exploding and everyone started moving there, they voted with their feet and they took their resources to Hoboken. So thinking about things like that. So that's part of it. And Thibault theory has evolved since the 1950s because that's what theory should do. And a lot of it has to look at how sorting works and how it works within, how it reinforces racial inequalities across different things. So it's economics, so people look at banking and how you buy homes and all the other things. I look at it, how it impacts education, because I study education. And then finally, I look at stratification economics, which is very similar to quant crit, which some of you heard our candidates talk about, I don't know, a month ago. And it integrates economics, sociology, and social psychology to analyze inequalities across groups. So thinking about how those structural issues have been there forever and how those historic things are now impacting the current day. So for my theoretical framework, I look at things like that a lot of us mentioned, right? So funding for advanced math courses, that's going to be an issue if you're in a neighborhood that does not have the resources. So that becomes an issue. The need for these advanced math courses. If you're in an area where the middle school was not providing a good math curriculum, why do you need AP Calc? If students are ending middle school in, I don't know what a middle school, I know the high school, huh? Pre-algebra, they're finishing with pre-algebra instead of with, exactly. Then this is an issue, right? So they can't even start their high school curriculum in the proper way. So they're never going to get to the advanced math. and the desire from the community for advanced math courses. So if we're thinking about things like gentrification and all of that. So as people move in, they change the schools and what they look like, course offerings, think about like dual language programs, anything like that. Those are all things that when people are voting with their feet, they're also changing the entire demographics and how the areas look. And so from there, looking at, so those are neighborhood resources, then looking at the high school resources. So whether or not you offer a course doesn't mean that it's the same thing as somewhere else, right? So if an AP Cal class is being taught by someone with a English degree, it's probably not going to go as well as someone who has a math cert, right? So thinking about the high quality advanced math courses. So what does that look like? And high quality math teachers. So making sure that those are aligned. And then from there, if you don't offer the courses, there's no enrollment for it. So that also impacts that. So looking at the enrollment. From that, if you're not even able to take the courses, what does that look like moving forward? What are your college chances even look like if you're not able to take the basic math courses that everyone else is taking in other schools with higher resources? And then also, what does that look like for STEM degrees? Because just looking at regular curriculum for post-secondary or for post-secondary for higher ed, you need to take certain math courses to just graduate. If you're in a STEM field, you need to take calculus and calculus 3 and all of those great things. But if you didn't take calc in high school, you're taking all the calc classes the entire time and playing catch up while your peers are going into college taking calc 3. So you're already really far behind and thinking about whether or not you can afford 5-6 years of college while everyone else can complete a degree in 4 or 5. STEM degrees normally take 5. So did this come out right? None of my animations came out right, and I'm very sad because I did work very hard on it. But I will. It might be because it's a pear deck. I could take the, looking at Albert, because if I take it off of this, I don't need the pear deck anymore. See? Yeah. See? Do you see why I was upset earlier? I was just like, there was things happening here. So here is where Montclair is. This is the normal school. This is where we are right now. These are all the green areas near us, which shouldn't be a surprise. We know where we were. If we look here, this is the Newark area, yellow and red. So C's and D's. So you're never getting a mortgage down here. So if we think about how the residential landscape of Essex County looks and where all the money is, it's following this map in particular. Blue is B. So A is green is the best. B is like just right there. Like you want to live there, but you would rather live in a green area. Yeah. Blue, I think, would be the equivalent of like, it's up and coming. It's almost there. It's not Montclair, but it's Montclair adjacent. Where was I? Yes. Okay. So this is, where we are right now. So the way that I put my data together is I use maps first before I put it into Stata and all the craziness that you guys are afraid of. Thank you, Helen Rose. So I use census data. So this is the block level data for all of Essex County. I'm only showing you one area because if I were to show you the entire United States, one, my computer would crash here, and also you can't, I feel like it's easier to see a place that you're familiar with. So this is the census block level data. This is the redlining data for the same area. So I layer them on top of each other. So this redlining data does not help as it is because it's very broad. It's by neighborhood, right? So like this huge yellow part, who cares? I wanted to see it by the actual block level. So I merged them together And we have this. So now you can see where the redlining areas are for each block level. From there, I have school district, high school boundary data. So these are high schools because I'm looking at high school data. I also have it for elementary schools as well. But this right here is the high school. So somewhere here is Montclair High. I looked at the maps. I'm not from Essex County. So these are the ones that were in that data set. From there, I layer it on, and now I have every single block level with the school that's attached to it with that redlining data and all the census data to it. On top of that, I include the civil rights data set from NCES, the National Center for Ed Statistics, which has things like what courses are available for that school. So what's the highest level math? What number of calculus courses were taught that year? What number of physics courses were taught? Any class that you can think of, they have the number for it for basically every 3 years. So I have it for 2009, 2010, and 2011, 2012. The reason I have it for 2009, 2010 is because I have a restricted access data set that looks at student level data across the country. And it's a nationally represented data set. So it's 15,000 students, but it actually represents over 2 million students when you look at the weights. So each student accounts for a certain amount of students. So using all of this, I'm able to see individual students and what they have done throughout their lifespan, from high school to 3 years after they graduated high school. So the high school longitudinal survey is, like I just mentioned, is a nationally representative data set. And it started in 2009 when they were 9th graders, and it followed them to 3 years post when they were supposed to graduate high school. So it has their course information for each individual student for those years. From high school, they have their high school transcripts. I have their, yes, Jaime. Yes, I do. I have their demographic data. So it looks at things like here I show you the demographic breakdown of each of the students that are in the data set. It also breaks down Latinx by type, not the way that we would love it to be, because I mean, it was 2009 and I didn't create the survey, but I can see the differences between Puerto Ricans, Dominicans, Cubans, sorry, Jaime, Central Americans and South Americans are their own groups. They're all together. But if I were, you would do it by each individual country and then also layer the race on top of it. And I'll talk about that in my limitations part as well. So it has all this information for high school and all of that. It also has what they majored in college. So if they went to college, what college they went to, the second college they went to, which degree they enrolled in, and their majors. So I can see if they're STEM majors for their first degree, for their second degree, their third, whichever one that they're doing. So all that information is there. I end up with 13,901 students. Yes, Jaime.
I'm not trying to be personal, but just to understand it. Okay, that it's also kind of, as you have the demographics and that breakdown, you have the residential location, because for instance, if you take Montclair, right, I mean, there are huge differences.
Yes.
You have.
Yeah, so I have where they lived, because I have their restricted access data. I know where they lived. I know where their parents are from as well. I know where their parents were born. So if they were born in which state they were born in, or if they were born in a different country, I have that information. I have things like what middle school they went to prior to it, what was their last middle school class, what was their first high school class, their test scores in 9th grade for math, their test scores when they graduated from high school, and their final mathematics course. Thank you, Jaime. So as I was saying, my final data set ends up with 13,000, about 14,000 students, and they represent about 2.8 million students because of the way that it's weighted and because of the way the data was collected. So each of these students are supposed to look enough like everyone else that we can mirror it. And so you can do these great, huge analyses. About a quarter of my data set is Latinx. And obviously 50% is going to be white. And this really does follow what high school population looked like in 2009, 2010. And then the other breakdowns are there: 14% Blacks, 8% multiple races, 3.44% Asian, and a very small number of American Indian and Native Hawaiians, which is normally the case. If we look at the demographics just for Latinx students across the country for this data set, 61% are Mexican. What's the next biggest one? 13% are other Latinx, 7.2% are Central American, 7% are Puerto Rican. So you can read it. I'm not going to read all of the demographics there, but that's how you can see it at a more finite level for the Latinx population. And if you're looking at who lives in historically redline areas, about 5% of the Latinx students within this data set are living in an area that was historically redlined. And this is in comparison to about 3%, a little under 3% overall. So it's a lot higher, and it's statistically significantly higher than the average for everyone else. And if you're looking at non-white Hispanics, it was only 1% of those students who lived in a historically redlined area. And then just thinking about things like calculus, which is normally the class that you should take by the end of high school to go on to a elite college, right? The majority of Latinx students are in schools that offer less calculus courses, regardless of the redlining designation. So it doesn't matter if they're in a redlining area or not. There are a tremendous amount of calculus classes that aren't being even offered. So let alone being able to enroll in these classes. So thinking about what does this mean for high school math course taking, right? So overall, about 43% of students take an advanced math course by the end of high school. So advanced math is anything from probability and statistics, calculus, AP Calc, and then this says other math, other advanced math. So things like Algebra 1, Pre-Calc, all of that, they don't count as advanced math. You need to be at calculus or beyond to be considered advanced math. And you normally need that math class to go to one of the elite colleges, but especially if you want to do a STEM degree within a certain amount of time. So 43%, and that's in comparison to 33% for the Latinx population. If we break it down, just looking at places that were redlined, 33% of people who are living in redline areas are taking an advanced math course. Only 23% of Latinx students are doing this. And then if you look at how the redlining works, so we go back to how the data set worked, right? So I do break down everything and you look at it by block level. Remember that high schools look like, the high school boundaries look like this. Well, in New Jersey, they do. They don't always look like this everywhere else. This is very, if we look at how many different little blocks have to be put in there, I have an average essentially. So it's a percentage of blocks that were redlined in that high school boundary area. So that's the difference for redlined. So if we look at places that were, they should both say 25%, there were about 25% redlined. 25% of those students go to they take an advanced math course. But if you're looking at Latinx student, it's only 20%. So it is disproportionately impacting Latinx students in a negative way. So what does this mean for by Latinx type? And I thought this was very interesting because I do hate it when everyone just gives me Latinx and calls it a day, because we live across the country and we look all very different and it's generational and all of that. Yes, Rachel. So the choice doesn't matter because it still covers the same boundary system. So all the schools technically have the same boundary according to how the school attendance boundary maps were collected. So like East, I'm embarrassed now because I went to college. I went to grad school there. Yeah, I'm not even gonna remember. Central High School. Yeah, they all have, anyone can go anywhere in Newark. So it doesn't matter. So it's just Newark, essentially. So each school has their own offerings, but the redlining, so the redlining for all high schools in Newark will be exactly the same, because it's all accounting for the same geographical area. But if we're looking at their course offerings, it's by school. So my data set's is by student. So it's student where they went to school and then what that school provides. Where was I? So if we're looking at things by type of Latinx student, right? There are vast differences across. South Americans are taking advanced math courses at a much higher level than most of the other groups. Cubans are a lot higher, and so are Central Americans, while Dominicans and Puerto Ricans are on the lower end. And that's regardless of whether or not they're in a redlined area. When I look at redline areas, it impacts Dominicans even more in a different way. So 52% of them are actually taking courses. And I could not wrap my mind around it. If you could explain it to me, that'd be great. But I didn't understand how it flipped. I'm thinking it's because there are less people there, like the number of people of Dominicans in redlined areas is a lot lower, because even when we look at it by places that were at least 25% redlined, it drops tremendously. Like I don't even have an observation number for it, so it didn't matter. So there are differences across, and I think that's important to note because everyone does analyses just as Latinx. Okay, so back to my research question, right? So how does the structural barrier, so how does redlining impact in advanced level course availability, and how is that impacting going to college and majoring in a STEM field? So I use a logistic regression to predict the likelihood that someone is going to major in a STEM field based off a bunch of their demographic information. So I have an explanatory comma on logistic regressions. So think about a nice little toy box, right? And think about the fact that this toy box only has blocks and balls in it, right? So we're trying to predict what the toy is based off certain things. The color of it, whether it's round, whether it's a square, whether it's at the bottom, whether it fits in certain places, any sort of thing that you can think about differences between blocks and balls. So you think about those differences, and then you can use all that information to estimate whether or not it's a ball or it's a block. So that's what I do with a logistic regression. So it's going to help you understand how you can put people into categories or how you can do all of that. It's used a lot in K-12 when we're trying to figure out if somebody needs any sort of emergency services in schools. I'm pretty sure higher ed does it as well when they're trying to figure out whether they need tutoring or something. So based off demographics, their grades, you plug it all in, and they're kind of flagged as a student who needs help. So it's along those same lines. So I'm using it to predict whether or not someone will major in a STEM field based off all my data that I have here, using race, ethnicity, or Latinx type. So I did 2 different regressions, socioeconomic status of their parents, redlining information, the percent of math courses that are calculus or above in that school out of all their math courses, whether they took an advanced math course in high school, school demographics, so the percent of students that are Latinx, the percent of students that are Black, and this is what the logistic regression looks like. It's all the way on the bottom, so it didn't, yeah, so no one got scared when it got all the way up on top. So from the logistic regressions, when I look at the results, being American Indian, Black, Latinx, more than one race, or Native American compared to white, lowered your odds of majoring in a STEM field for your first degree. This is not news, right? Being Asian increases the odds in comparison to whites, also not news. We see the demographics of our majors. The odds of someone majoring in STEM are 1.04 times higher for each percentage point increase for the percent of calculus courses offered in a high school. So if one school offers 20% of their math courses are calculus and another one offers 21%, it increases that student's chances of majoring in a STEM field by 1.04. And that is an incredible amount. The odds of someone majoring in STEM are 1.16 times higher for each percentage point increase in redlining. That should say lower. They're lower. So every time, so if it was 25% redlined, that district or that high school, the school that was 26% redlined, all those students have 1.16 times lower chances of majoring in a STEM field in college. The odds of someone majoring in STEM are almost 5 times higher for people who took advanced math. This should not be a shock. Most people who take advanced math actually enjoy math because, and they probably want to keep doing it. Or they just know that they could finish a degree within 4 years, 5 years without breaking the bank or being in school for 20 years. And then the odds of someone majoring in STEM are 1.6 times higher for each increase in the socioeconomic status composite. So the high school longitudinal study creates a composite based off of income, the where they live, their parents' jobs, and creates a SES composite based off of that. And the higher the composite is, the more affluent they are. And then an increase in a percentage of Black or Latinx students in the high school decreases the odds of majoring in STEM. When we look at it by Latinx type, being Mexican, Dominican, Puerto Rican, or other Latinx reduces your odds of majoring in STEM in comparison to whites. Cubans, Central Americans, and South Americans have higher odds of majoring in STEM than whites do. And for the most part, all of these are going to be very similar. The trends are the same, and maybe they're off by like a point, but the point is of all of the rest of these bullets is that if you are offering more calculus courses, students will have a higher odds of going on to a STEM field in high school and college. If there is redlining, it decreases the percentage of going on. And then someone majoring in STEM, if they took advanced math, also increases it. And so does your socioeconomic status. So those were similar in either regression. I just wanted to separate it out by Latinx type to see what the differences were there. Some of the limitations for my work is that there are other issues that go into course taking. I'm very well aware of that. There's district policies, what can be offered, what should be offered, state level policies, all of that. There's also tracking in middle schools that occur. So if you're in a neighborhood that is already tracking you, when you get to the high school, no matter how diverse or how great that school is, you've already been tracked in middle school. So if you're not where you should be in high school, it's really difficult to already get you to advanced math. Teacher availability, teaching math is a lot. And math teachers could do other things. So making sure that we have high quality teachers to teach all these advanced courses. Tracking that occurs within schools and through schools. Counselors are also a very big part of this, right? So what are students being encouraged to take these courses? How is that working? Are they automatically being placed in certain courses? There's a lot of districts now where students are placed in courses regardless of skill, just because they want them to take the class. And also family structure, what's going on at home? Do you need to rush home and take care of your little sister? Is there, you need a job? All these things also contribute to all of that that aren't necessarily in that SES composite. And there's obviously other issues that go into major choices and college attendance that aren't going to be in this data set. And it's also why I looked at only the first major that they picked, because I know that whatever happens in higher ed is completely separate from their whole K-12 experience. I just wanted to know what happened when they left that high school and they said, this is what I want to do for the rest of my life. And the fact that they even thought about being in a STEM field is a lot bigger than a lot of other students could say. Some implications and future research questions. So like I said earlier, the Latinx student population is the largest growing population in the United States. So if this population isn't getting the resources that they need because of where they're living and the resources that are there, what does that look like for the country moving forward? many do live in these historically redline areas that have less resources. So residential segregation is impacting schools through resources and all of that. Just aggregating the data is very necessary, as we can see just from the way that they collected Latinx types. If you were able to look at things like immigration status, race on top of Latinx, because it is very different, country of origin, generational status, any of those things would change a lot of it. And what's the difference, right? So like the fact that certain populations, certain subgroups are doing well, even though they're in redlined areas, what's going on there? What's the impetus for that? And schools in historically redlined areas are offering less advanced courses. These students are taking less courses and they're going into STEM at a much lower rate. So if we are to think about the STEM field moving forward, education moving forward, what are the resources that need to go into this system to fix this very long line of historic structural racism that has been occurring?